Alright, so the other video actually got corrupted, so this is from my Algebra 1 students for their test tomorrow. I'm going to go ahead and redo this really quickly. We're going to run through it in the next few minutes. Let me go ahead and see. We're going to cover all the topics that you would have on the test. Keep in mind most of it's just equations, absolute value, and literal equations. Well, they're all just different types of equations, so should be simple enough. Let's start with a basic equation. A basic equation does this. Keep in mind that there are a few priorities that you're going to use for this test. Now, this isn't set true for every single equation in the world, but typically you want to clear denominators first. And then you want to clear out any addition and subtraction. And then last, you want to get rid of any multiplication. Okay? And as a typical whole, simplifying each individual side is the best first step. Okay? So typically you want to simplify, then deal with any denominators, then deal with addition and subtraction, and then last we'll deal with multiplication. And this is going to be true for the majority of your problems. Let's go ahead and take a look at just a basic equation to start. All right? So a basic equation would be something like this. 2n plus 5 equals n minus 7. Okay, so a basic equation looks just like this. And what you're going to be looking for is you're going to be aiming to get n all by itself. You'll notice here that we have a lot of like terms. Remember, like terms is anything with the same variable to the same exponent. So these both have n's, they are like terms. These two do not have letters, therefore they are like terms. So what we want to do is combine our like terms, and it doesn't matter which order. So I have a plus 5 or a minus 7. I could either move the minus 7 to the left or the plus 5 to the right. It does not matter which way. That's completely up to you. I'm going to go ahead and subtract this 5. So I'll subtract 5 from both sides. Remember, what I do to one side, I have to do to the other side of the equation. So after we subtract 5 from both sides, 5 minus 5 is 0, and negative 7 minus 5 is a negative 12. And then the rest of this equation, we're just bringing on down. The 2n comes right on down, the n comes right on down, and then negative 7 minus 5 was that negative 12, so we're right here. From this point on, we want to continue combining our like terms. Earlier we said these were also like terms, so let's go ahead and get them together. You could move this one to the right, or you can move this n to the left. It does not matter which way. I'm going to go ahead and move this n to the left, just because it's going to reduce my problem by one step. So we subtract n, n minus n is 0, and that's the goal. So on this right side, all we've got left is negative 12. On this left side, 2n minus 1n is just n. N equals negative 12. After you get your n all alone, you're done. That's all a basic equation is asking you to do. Okay, a little bit more complex. I'm going to go ahead and do an example that includes a bunch of different elements of this. So let's go ahead and take a look at one more equation, a little bit different this time. It's going to have a couple more elements in it. Something like 3x over 8 plus 7 equals 13. Okay, some example like this. And given this example, we have a couple of things. So you'll notice that we have a couple of different elements. First off, can we simplify? So that's your first step all the time. Can you simplify? And we take a look at this, and you'll notice that there's nothing really to simplify. I can't really divide 3 by 8. You can turn it into a decimal, but that's not really going to help your problem. You can't add 7 to this because they're not like terms. This 13 is all by itself over there alone. You could simplify by combining those two, but let's go ahead and do it in the order that we found. And again, you can do this in multiple orders, but you'll notice that we do have a denominator. We do have a denominator, and we do have addition, subtraction, and we do have multiplication. All of these things are things that we have. So you could actually get rid of this in multiple ways. For this particular problem, I'm going to go ahead and subtract my 7. Okay, so over here, I'm going to subtract my 7 from both sides. What you're going to end up with is just 3x over 8 is equal to 13 minus 7 gives you 6. From this point on, we're just going to get rid of things in order. So we've got a denominator here. Let's go ahead and move it. So the opposite of division, this is 3x divided by 8. The opposite of division would be multiplication. We'll multiply both sides by 8. Given this, these 8's will cancel out because 8 divided by 8 is 1. So you're left with just 3x on the left side. Oh, sorry. And then over here, 6 times 8 is 48. Now our last step is multiplication. We have 3 times x, so the opposite of multiplication would be division. Divide both sides by 3. 3 divided by 3 is going to be 1, so you're just left with x on this left side, and 48 divided by 3 is 16. So you'll bring down your x, and you'll simplify over here. 48 divided by 3 is 16. And you would be done with your problem. You'll notice with this one that I chose to do the addition subtraction before the multiplication. If for whatever reason you decided that you really badly wanted to do that, deal with that denominator first, which you could, there would be no problem with that. It would look like this. And here's the reason I didn't do it. So plus 7 equals 13. When I multiply both sides by 8, you have to remember to also multiply that 7. That can get confusing. Okay, so these 8's will still cancel, but you still have to distribute this 8 to that 7. So you end up with 3x plus 56 equals 13 times 8, which would be 104. So this becomes kind of a messy problem with much bigger numbers, but we could just subtract our 56. And then 104 subtract 56 is going to give you a, let's see, 48. And then you'll get that same x equals 16. So you'll notice that this one actually took one less step than the other one did. It's just a little tiny bit shorter. Let's see, 1, 2, 3, 4. 1, 2, 3. Yeah, it took one less step, but there was that simplification step, so it really makes no difference. Both problems turn out the same way. Both problems are pretty much equal length. They're not really all that different. You're welcome to do it either way. So you'll notice that this is not a steadfast way to do it as long as you're practicing sound math. So as long as you're practicing sound mathematics, it actually does not matter what order I do this in. All right? So that's basic equations. Now let's go ahead and talk about how to deal with absolute value equations. So let's steal this one from the book. So these are absolute value equations. So with absolute value equations, you'll have something like this. 2x plus 1 equals 3. And the absolute value of this. Okay? So let's go ahead and go with a step-by-step process of how this works. Your first step in any absolute value problem is to go ahead and, isolate the absolute value. This is actually a pretty easy step in most of the problems. You might get a problem every once in a while that'll have something sticking off of it over here. But as long as your absolute value is all alone, you're good. So let's go ahead and rewrite it. It's the same thing. We've already isolated it. There's nothing outside of my absolute value sign. So you'll notice that there is nothing over here, nothing over here. So we don't have to actually isolate it. It's already all alone. Okay? So ignore those. Now that it's all alone, your next step is actually fairly simple as well. You're going to go ahead and you're going to rewrite it. So step 1, step 2, rewrite your equation twice without the absolute value sign. So without absolute value. Okay? So what that looks like is this. So we're going to take our same equation, 2x plus 1 equals 3, and we're going to write it without those absolute value bars. Okay? 2x plus 1 equals 3. 2x plus 1 equals 3. Now that we're here, our third step is going to be go ahead and put parentheses around the variable side of the equation. So whichever side has the variable is the side that you would want to put parentheses around. Oh, sorry about that. So put parentheses around the variable side of the equation. and add a negative sign. I feel like on my last recording I worded this better, but that's okay. It'll make more sense once I write it out. So let's go ahead and do what this says. So put parentheses around the variable side of the equation, and we're going to do this to this right one, okay? The first one we're just going to rewrite. So the first one you're just going to write it 2x plus 1 equals 3. The second one, you're going to put parentheses around the variable side of the equation. 2x plus 1 equals 3. I should have done these in different color, actually. So you'll notice that the only difference between these two is that there's a parentheses around this one. There is no parentheses around this one. And I put it around the whole thing. And then tack on your negative right there. Okay? Now we'll just solve. So step 4, I'm going to go ahead and start this on a new sheet of paper. So step 4 is just solve for x in both. So solve for x in both equations. So both of these have different answers, and we're going to find out what they are right now. So let's solve this left one first. 2x plus 1 equals 3, negative 2x plus 1, 3. Okay. So let's just solve for x. This one again, you've got a plus or minus, so let's go ahead and deal with that first. Subtract 1, 2x, these will cancel. 3 minus 1 is just 2. Now that's 2 times x, the opposite of multiplication is that division. And then 2 divided by 2, 2 divided by 2, you'll get x equals 2 divided by 2 is 1. All right. On the right side, we've got a couple extra steps. First, let's distribute this negative sign. So this was a positive 2x. It's going to change. It's now a negative 2x. And then this was a positive 1. It's going to change. It's going to become a negative 1. So that minus sign outside of parentheses, you'll have to remember, just means that we take everything on the inside and change their signs. If they were positive, they're now negative. If they're negative, they're now positive. And the right side stays the same. From here on, it's just like this problem. We're just going to get rid of this minus 1 first. To get rid of a minus 1, you add 1. Always do the opposite and make sure to do it to both sides. So plus 1 minus 1 cancels out. 3 plus 1 is 4. And then we'll have to get rid of that negative 2. So that's negative 2 times x. The opposite of multiplication is division. So we divide both sides by negative 2. You will end up with x is equal to negative 2. All right. And that is the end of your equation. Your two answers would be x equals 1 and x equals negative 2, which you can absolutely plug back into the original equation to test and make sure that is right. Okay. So all absolute value equations have two separate answers. Sometimes they could turn out to be the same answer, but on my test, they'll all have two separate answers. So make sure that when you do absolute value, you do have two separate answers for me. All right. Absolute value equations taken care of just like that. We're going to go ahead and move on to one last topic. And that's literal equations. So literal equations was the last thing that we're going to be covering for this chapter. Literal equations. And these are the ones that don't necessarily have that many letters. I'm sorry, they don't have that many numbers, but they have a lot of letters, and you have to solve for things. So literal equations. This would be something like V over R equals I. And they want you to solve for V. So solve for V. This is one of the more basic literal equations, but all you would do with this one is you would take a look over at your formula here, and you would ask yourself, all right, well, I need V all alone. So I need to get rid of whatever is not V over here on this left side of the equation. The only thing on the left side of this equation that's not V is this R. So the question now is, how do I get rid of this R? You'll notice that's V divided by R. So the opposite of division, you guys have told me before, is multiplication. So we're going to go ahead and multiply both sides by R. R divided by R cancels out. You're left with just V on the left side, and that was your goal. So whatever it says to solve for, you just need it all alone. Congratulations, it's all alone. Hooray. That's all you really needed to do. And then over here you have I times R. And you can write this as IR, RI. Doesn't really matter. I like them in alphabetical order, but that's just a personal preference. I will not mark you wrong if you write this as V equals RI. Really doesn't make a difference to me. Okay, and mathematically it doesn't mean anything. Okay. So let's do a little bit harder of an example. Something like this. V equals, let's do this one in black. So something a little bit harder. I'm just going to do two of these examples. V is equal to 1 over 3 s squared h. Now this one has pretty much everything that you could possibly want in an equation. Has pretty much every operation. So let's go ahead and start dealing with it. We want to get, for h. So we want to solve for h here. All right, and if we want to solve for h, that means we need to get this all alone. So we're looking at this right side of the equation. So this is our variable of interest. We want to get that all alone. So we got to get rid of this s squared. We got to get rid of this 1 over 3. So let's talk about it. Again, remember, whenever we're dealing with equations, dealing with denominators is the easiest first step. So remember, you simplify, denominators, addition, subtraction, then multiplication. So denominators is top of the list. You'll notice we have one right here. So if we get rid of this denominator, so instead of a divided by 3, you want to do the opposite. The opposite of division is again multiplication. So we're going to multiply both sides by 3. This 3 is actually going to cancel out with this 3 because 3 divided by 3 is 1. And don't forget, what you do to one side, you have to do to the other side. So far our equation looks like this. 3 times v is equal to the 1/3 and the 3 canceled out, so now you just have s squared h. So now you need to get rid of that s squared. That's s squared times h. To get rid of something multiplied, again, you always just divide. So divide both sides by whatever you need to get rid of, which is that s squared. You don't want to get rid of your variable of interest. So your h here, you definitely don't want that to disappear. So let's go ahead and get rid of the s squared. S squared divided by s squared, anything divided by itself is always 1. So those just cancel out. And you've got h all alone. Now that h is all alone, the other side you just rewrite. So it's 3v all over s squared. And you'd be done. This would be your final equation. You could also write this in the other order. H is equal to 3v over s squared. It doesn't matter which way you have it, left or right. That's an h. Does not matter in the slightest whether or not it's left or right. So again, all of these problems, no matter what they are, you're prioritizing simplifying, then denominators, addition, subtraction, and then multiplication. So as long as you know how to do that, this is how that works. Let's go ahead and, just because this video isn't too long, I'm going to add one last example. One last example on here, and this one will include numbers as well, just a larger number of numbers. That way we can see what happens with that. Something like negative 2x plus 5y equals 7. And then we want to solve for y. So solve for y. You'll notice that's right there. So that's what we need to get all alone. We need to get rid of this stuff. This 2x and this 5. This negative 2x and 5, we got to get rid of it. So the opposite of a negative 2x, I mean, obviously you'd go through your checklist. So can we simplify? So can you combine 2x and 5y? You cannot. They're not like terms. That has an x, that has a y. Different letters. Can't do anything about it. So we just move on. So we can't simplify. Do we have any denominators? You'll look. You don't have any fractions. You don't have any denominators. Can't do anything. So that's fine. And then do we have any addition or subtraction? We absolutely do. Okay? And you typically want to get rid of whatever's not your variable of interest. So since we want to keep y here, we don't want to just get rid of plus 5y. Okay? It's all attached together, so we can't get rid of one without the other. So let's go ahead and get rid of whatever's furthest away. So if y is all the way over here, let's look all the way over here and get rid of whatever's over here. To get rid of minus 2x, you do the opposite to both sides. Okay? So minus 2x plus 2x cancels out. You're left with just 5y. And then over here, 7 plus 2x. Again, this doesn't have a letter. This has an x. They're not like terms, so you just write them right next to each other. All right. Last step, this is 5 times y. I need to get y all alone, so how do I get rid of that 5? So it's 5 times y. You want to do the opposite. Divide by 5. Divide by 5. 5 divided by 5 is 1. You're left with just y. And then over here on the right side is just everything else. And you're just going to rewrite it. 7 plus 2x over 5. Again, if you wanted to write it like this, 2x over 5 equals y. It doesn't matter. Both of these are acceptable answers. Both of those are exactly the same. Feel free to rewind and pause and do whatever you need to do, but equations all work the same way, and it's all about practice. So take the time to do all the equations in your book and maybe learn to write your own equations, because on your test, the way that your test looks is I took a problem like, actually this is a good example. I took a problem like v equals IR, and then I make it a equals TV or something like that. It does not really matter. I can change whatever order or whatever letters for this one here. Something like 2n plus 5 equals n minus 7. I made this 3b plus 2 equals b plus 1. I don't know. It doesn't really matter. That's not actually on the test, but the idea is that's how I'm creating the test. So if you need to study or if you need to practice more, take all those problems from out of your quiz and test book and change the numbers. That's probably exactly what I did. As long as you can do that, you should be perfectly fine. Hopefully that covers all of your material on the test. I'm so sorry that this is going out so late, and I really wish that it could have gone up properly before, but I corrupted the file somehow. So hopefully that all works out. Best of luck on your test tomorrow, and I will see you guys in class. Good luck.